In this video, we're going to talk about function notation. Function notation is when we write a function as an equation. So let's make a note. To write a function as an equation. And you want to think of function notation as naming a function. So like f of x and g of x and h of x. These are all like names of functions so that we can keep them separated when we're talking about more than one at a time. So we'll make a note of that. For example, given the equation y equals 3x plus 1, solve for y when x equals 2. In function notation, it would be just written as f of 2. And that means to solve for y when x equals 2, it's just written in shorthand. And you're doing the same steps for solving it. So let's look at some examples of what evaluating a function would look like. So before we do that, let's actually look right up here at this function notation box right here. So notice your y is still your output. Your x is still your input. And the name of the function is whatever letter they choose to put right there. So it could be any letter of the alphabet. But that's just the name of the function to help us keep them separated. So again, we could talk about more than one at one time. So examples of evaluating a function. So if we were asked to solve for f of 3 or evaluate for f of 3, all that means is to find y when x equals 3. I'm going to write that. Find y when x equals 3. That's what f of 3 means. So you go to the f function, because that's what they've said, and you're going to plug in x equals 3 to figure out that value. So we would say that's equal to, so f of 3 would be equal to 2 times 3 minus 5. So all we need to do is simplify that expression. So 2 times 3 is 6, and 6 minus 5 equals 1. And so f of 3 equals 1. That means y equals 1 when x equals 3. That's what we have found. So in this one, we could say the same thing. So f of 3 would equal 3 times 3. We're just plugging in that x value where it is in the function. So wherever it is, you plug it in. So we get 9 minus 1, and that's just 8. So we have found that f of 3 equals 8. And that means y equals 8 in this function when x equals 3. That's what we have found. All right, so the same thing over here. If we're going to solve for g of negative 2, so we're going to find y when x equals negative 2 for g. So we go to g of x, we say g of negative 2 would be 5 times negative 2 plus 4. And then just clean that up. So 5 times negative 2 is negative 10, and then plus 4 would give us negative 6. So we figured out that g of negative 2 equals negative 6. In other words, x equals negative 2 when y equals negative 6, or y equals negative 6 when x equals negative 2 for the g of x function. And then let's do that one more time. So let's find g of negative 2 for 7x minus 5. So just do 7, plug in negative 2 for x, and then let's clean that up. So 7 times negative 2 is negative 14, and then subtract 5, and we get negative 19. So we have found that y equals negative 19 when x equals negative 2 for the g of x function. All right. So then you can also use mathematical operations can be applied when using function notation. So addition means that you just take two functions and you add them together. So f of x plus g of x would mean that we take those values we're given. So f of x is 2x plus 4, g of x is 3x minus 1, and we're going to add them together. So 2x plus 4 plus 3x minus 1. And then it's just a matter of combining like terms. So 2x plus 3x, that would give us 5x. And then 4 plus negative 1 would give us 3. And so that's it for that example. Then to subtract, we could say f of x minus g of x. We could subtract any two functions. So we could say 2x plus 4, that's f of x, minus g of x, which is 3x minus 1. So you would definitely want to include these parentheses since you're subtracting a group of things. Adding is not as particular as subtracting is, so you got to be careful. So we have 2x minus 3x. That would give us negative x. And then we have 4 minus negative 1. So 4 minus negative 1 turns into 4 plus 1, which would be 5. All right, so multiplication means we can take two functions and we can actually multiply them together. So that would mean we could take f of x, which is 2x plus 4, times g of x, which is 3x minus 1, and we can multiply them together. In this case, that would mean we have to FOIL them. So 2x times 3x is 6x squared. Outside would be 2x times negative 1, which is negative 2x. Inside would be 4 times 3x, which is 12x. And then 4 times negative 1 would be negative 4. And then we just want to combine like terms. So we would get 6x squared. Negative 2 plus 12 would give us 10x minus 4. So we could just put those together. So we can multiply two functions, we can add them, we can subtract them, and we can divide them. So that would be f of x divided by g of x. And you would just write it 2x plus 4 divided by 3x minus 1. Or you could even write it 2x plus 4 out to the side and then divided by 3x minus 1. But then there wouldn't be anything more we could do with it at that point. And then scalar is to take a number and multiply it by the function. So like if you have 3 f of x, for example, that means to take like 3 and multiply it by 2x plus 4. So then we would just distribute the 3 and get 6x plus 12. And the same thing for any function. So if you wanted to do another example, we could say like negative 2 times g of x. And it just has to be sitting out front to mean the same thing. So negative 2 times g of x would mean to say negative 2 times 3x minus 1. And that would equal negative 6x plus 2. All right. So let's look at a few more examples of function notation. These are examples of evaluating a function from its graph. So on this first graph, if they ask us to find f of negative 1 and f of x is this graph, you have to go and find y where x equals negative 1. So remember, that's the main idea. You're finding the y when x equals negative 1, like for this first example. All right, so I'm going to go to x equals negative 1 and look at the red graph that's like the function that's graphed is in red. And so y equals 0 right there because that's the point on the graph. And so that's all I would need to do for that one. For f of 1, I need to go where x equals 1. So where x equals 1, I got to go down to the graph of the function and pick that out. So y equals negative 1. And then where x equals 3, so I've got to go to 1, 2, 3, and then go to that point on the function, and I see that y is equal to 2. So then we find, the next question is saying to find x when f of x equals 4. So that's like where y equals 4. So you got to switch your mindset and go to where y equals 4, and then go to the function. So it looks like it's going to cross around, what's that, 1, 2, 3, 4. So I would say it looks like it's about 4. All right, so let's look at the next question. It says f of 4 for this graph. So for g of x, go where x equals 4. So where x equals 4, y is equal to 4. So that would be my answer. And then I would go to where x equals 8. So go over here to x equals 8. And it looks like y is equal to 6. So that's all you got to put for your answer there. And then where f of negative 6, so where x equals negative 6. So we go there, go to the graph, and just pick out the y value, which looks like it's 5. And then last but not least, it says find x when f of x is 2. That means when y equals 2, you're looking for the x value this time. So I see where y equals 2, x would just equal 0. All right, so given the same thing on a piecewise graph, we're going to talk about this one together. So let's just say that is enough for the notes for now.